Hi guys, it's Miss Began, and we are continuing our conversation with solving systems of equations. We've done systems of equations by graphing, so we graph two linear equations, find the intersection point. We've done solving systems of equations by substitution. We get a variable by itself, and we plug in whatever that variable is into the other equation. And we also talked about elimination. So for elimination, we look at our two equations. We have 2x plus 4y equals 10, and then negative 2x plus y equals 15. We were looking at the variables, which ones had the same coefficients. And so here it was the x's, here as well. And then we look at the signs. So they have the same coefficient, positive and a negative. So when it was opposite signs, we added them together. And then when they had the same sign, positive 3x and positive 3x, we subtracted. And we did that throughout the equations. So we're going to look at an example here today, also using elimination, solving systems of equations by elimination. But we're looking at an example where when we look at the variables and look at the coefficients, they don't seem to match up. I see a 2x and a 1x and a 2y and a 4y. We don't have the same coefficients for either variable. And our goal is we have to eliminate one of the variables to be able to plug in and find the other one. So how do you think that we're going to solve this? How are we going to get either x by itself or y by itself? Yes, we could multiply an equation to try and get both variables or the numbers to match up. So I'll show you what that kind of looks like. We'll pick either x or y, whichever one we think is going to be easier to try and get to match the other coefficient in the other equation. So we have a 2x and 1x. We have 2y and 4y. I think because it's 1x, it'd be really easy to get the 1 to be a 2. What would we need to multiply 1x by in order to get it to be 2x? 2. So what I'm going to do is I'm going to multiply. I'm going to distribute, remember distributive property, I'm going to distribute a 2 to all of these terms in this equation. Green doesn't show up as well, so I'm going to switch markers. All right, so if we multiply 2 times x, we'll get 2x. If we multiply 2 times positive 4y, we're going to get 8y. And if we multiply 2 times a negative 13, we're going to get a negative 26. Okay, so this is our new equation. It's still proportional because we distributed the 2 to every term. Make sure you do it throughout the whole, even on the other side of the equal sign. So I'm going to eliminate that equation just so I don't confuse myself. So now our system of equation, the two equations we're going to use, is the original top one, but this is now the recreated distributed new bottom equation. So now we have 2x. Both the x variables have the same coefficient, so we can now do the process of elimination like we did over here. This is a positive 2x, that's a positive 2x. So since they both have the same sign, we know we're going to subtract. Same sign, subtract. So let's subtract. 2x minus 2x gives us, canceled out. Negative 2y minus 8y, negative 2 minus 8, it's going to give us a negative 10y. And then 14 minus negative 26 minus a negative means we're adding a positive, doing the opposite. So 14 plus 26 is going to give us 40. All right, so we have negative 10y equals 40. And we know we do the inverse operation to get y by itself. So we're going to divide since that's multiplication. And y equals negative 4. Awesome. Y equals negative 4. So now that we've figured out y, we can plug in y to one of our original equations to solve for x. Which one do you want to plug it into? You want to do this one? Okay, we can do that. You can also use the revamped equation, the proportional equation, to do that and to plug it into. I just like to go back to the original ones. So I'm going to plug negative 4 in for y into this equation. X plus plus 4 times negative 4 equals negative 13. So notice I just plugged negative 4 in for y. So it was 4 times y. So now I have 4 times negative 4. So I'm going to multiply that out. Negative 16. And then when it's plus minus like that, it's kind of like subtracting 16. So to move it to the other side, I'm actually going to add 16, do the opposite. And then x equals 3. Negative 13 plus 16 would be 3. So now I have my ordered pair, negative 4, 3 comma negative 4, that solves this system of equation. This is the ordered pair that can be plugged into both x and y's in both equations to be the solution. So let me know if you guys have any further questions, but this is solving systems of equations by elimination. Hey, thanks for watching, and don't forget to subscribe.